Hey, what's up, everybody? I'm Jason, and today I'm here with Johnny from Turbo Makes Games. We're going to be talking about performance, C# performance specifically, the job system, dots, ECS, and all the different things that you can do to make your games run fast, or just give you some updates on where that stuff's at and whether or not you should be using it. It should be a really fun and interesting conversation. So if you're into game development, you're building games at all, and you want to know about the future of game dev, especially in Unity, then make sure that you stick around, hit the like button, subscribe, and all that stuff. And also go check out his channel. We're going to be talking about what he talks about on that channel in depth and give you a good idea of why you'd want to listen to him and see what he's got to offer. But I recommend that you just click over there right now, go hit subscribe, and be ready for it. So that way you start to see the things right after this stream ends, or this video ends. Right after this video, right after this video ends. Get that in. All right. Anyway,
Awesome.
welcome, Johnny. Thanks for coming on here and being here with me. I'm really excited to have you here and just talk about performance, job system, dots, and all of that stuff. It's something that I don't keep all the way up to date with, and I'm sure a lot of the people watching and listening here don't keep up to date with it completely. And you're going to be a great source to fill everybody in on where we are with all that stuff, what types of things we should be doing, and all that. So yeah, I wanted to say thanks for being here first before anything else, and just let you say hello.
Yeah, absolutely. Thanks for having me. Hello, everyone. Thanks so much for watching. I think it's going to be a real fun conversation today.
Well, so I guess just before we get started, before we start losing people and getting overly complicated, can you just give a real quick like overview of what the acronyms are, like what job system is, what ECS is, what dots are, and just like an overview of like where they lay, and then we'll talk about them more in depth as we go on. But I'm gonna give
Yeah,
everybody an overview, like if they've say they're new to Unity, they've only been using it for a year, they write mono behaviors, they write scripts, they make games. What is all this other stuff do they need to know about it? Like, can you
yeah,
give us a
totally. I
quick
think that's
overview?
I think that's a great place to start because a lot of the stuff gets like kind of complicated and we can kind of get in the weeds of everything. But if you're not familiar, I think this would be a good idea to just give a quick little overview so everyone's on the same page here. So I think probably the best place to start would be with dots. That's kind of like the whole like overarching thing that Unity's working towards. So DOTS is an acronym. It stands for the Data Oriented Technology Stack. And Unity basically advertises it as kind of like performance by default. So it's really their, kind of high performance tech stack. And then under that, there's a bunch of things inside of DOTS. So that's kind of like the overall thing. You'll hear people refer to just DOTS in general. And so inside that, then you have like a bunch of different things. So there's ECS, which is the entity component system, which I'm sure we'll be talking about more in depth. And then you also have the job system. I'm sure many of you have probably heard of the job system, and this is just basically multi-threading within Unity. Maybe we can go into that a little bit as well. But also inside the data-oriented technology stack, we have things like the new physics system. That's where the Havoc physics system is, because Unity now integrates with the Havoc physics system. So that's technically part of their data-oriented technology stack as well. And then they have a bunch of other things that are still in like very experimental phases, such as the Dots multiplayer suite. There's some animation stuff and a bunch of like other sound things. But those things are definitely still in like the really early phases of production.
Okay, so dots or the data oriented tech stack is kind of just a conglomeration or a big group of all of the different products that build up, I guess, that stack that's focused on being oriented around setting data first or data first, right? Like the data layout and management being a primary focus of that, I guess, that stack and the way that all of these systems are built. And that's
Yeah,
primarily
yeah,
focused around performance.
yeah,
Um,
totally.
Cool. So I guess if people are looking at dots or this dots and all of these systems in there, do they need to take the whole thing all at once? Like, so let's say I'm new to this and I'm kind of curious and I want to look at, maybe the job system or ECS or something else. Maybe got a little bit of info about them and I'm kind of curious. Can I just use one of these things and just pull in part of dots without pulling in the whole thing, or do I need to make a complete shift and switch everything over?
Yeah, so there are definitely parts that you can like, pick and choose from. The job system is a great example of this. I'm sure if you've kind of like looked into this a little bit, you've seen that you can implement the job system just in regular mono behaviors. And I do think that is a great place to start start thinking in sort of the like data oriented way and start getting yourself familiarized with ECS programming. The main reason I say that is because with the job system, you have to use only blittable data types. So this is basically they're just value types. There's no like class references or anything.
Can
So
you
just think
define
of
that a little bit more just for anybody who doesn't know what a blittable data type would be?
yeah. So that would be some examples of that would be things like ints or floats, just like basic simple things like that. When you get into data types that are like strings or any kind of custom classes or mono behaviors, those are not blittable data types, so you cannot use those actually with the job system. Um, so the job system it really focuses on doing multi-threaded and like doing like crunching math calculations basically on just these basic blittable data types. And kind of the reason is because um, basically the computer doesn't have to go somewhere else to reference the data. Like when you pass it into the CPU, it's just getting the actual data like right there off the cache, and it doesn't have to go anywhere else. And that's basically how we can start to take advantage of the multi-threading of the job system.
Right. So, what kinds of problems do you see people solving with the job system? So, say we haven't moved on to switching to the full dots or ECS or anything yet. Just starting to implement the job system as part of a different project that's using mono behaviors. Are there any really interesting examples of things that you've seen people solve, or benefits that they got, or reasons that they started to implement it?
I'm trying to think of some good concrete examples, but basically, you want to use it when you're doing calculations across like many different objects. Is probably like one of the most like typically used cases, I guess. The reason for that is because when you do multi-threading, and you start separating out the work. When you do a calculation on one bit of data, you can't necessarily access that from another thread when it's doing that. Otherwise, you could get into all sorts of weird, complicated issues. And that's kind of one of the biggest things with multi threaded code. One of the biggest issues is something known as a race condition, where you don't necessarily know which CPU core is going to complete the work first. So you can't necessarily rely on the order that the data is calculated in. So it works best when you're like doing calculations across a bunch of different objects because they don't necessarily need to talk to each other at that one specific moment.
Okay. Yeah, I've seen kind of the same where it's just scenarios where there are lots of things that need to be processed, not so much like one complex thing that needs to be processed, but lots of little things, or sometimes some complex physics simulations as well. But most of the time, what I've seen people use it for is like just large numbers of things going on, and they're hitting a kind of a performance bottleneck when they're doing it single threaded. And for anybody who's not really familiar with Unity and starting to get into it, if you're using things like coroutines to kick stuff off asynchronously, they're not actually multi-threaded. You're not really
Correct.
using like your second core or your 16th core if you got, or whatever, however many cores you got. Or even like on a phone now, you got like 8 cores on one of these little
I
things.
know.
You're not
Yeah.
using all of those cores when you're doing it. So the job system
Yeah.
will allow you to kind of start to take advantage of that. And one of the things, I don't know if you've seen this a lot, but I've seen a lot of people doing mobile development get really interested in this tech stack and the job system in general for performance reasons and power reasons. They're able to save energy, save battery life, which is always a nice payoff, but also just to be able to perform well on older devices. Because if you can run on 8 cores of a 4-year-old device, it's going to run a lot faster than running on 1 core of that 4-year-old device, right?
Yeah, totally. That's honestly one of the things that I'm most excited for just about the whole data oriented technology stack in general is, it's bringing more opportunities to lower powered devices. Everyone, of course, has a phone these days that, has a, decently powered CPU to varying degrees. And, things like the job system, it really scales to whatever device you're working on. So just to give people a little bit of more info on kind of how the job system works, basically you set up a job, you kind of like define this job of work, and then you actually, when you want to execute it, what you do is you schedule the job, and then basically all the jobs that you have kind of queued up in the schedule, across however many different objects or however many times you're trying to run that job, kind of gets queued up. And then so you have your main CPU core, which is just kind of processing the main stuff in your game, which would normally be happening just on that one single thread. And then all your other cores and threads in your computer, those are basically designated as worker threads. And then they'll basically just kind of pull from that queue one by one. And so they can do work alongside the main thread. So, your main thread isn't bottlenecked by you, calculating things on thousands and thousands of different objects.
So you're keeping your performance nice and high there with that primary thread and all of the main gameplay loop, and doing things in the background. Like for instance, you could be generating a world in the background that's getting spawned in, and doing that asynchronously on another thread that's all happening kind of in the background and pops up without hitting your performance on your primary thread at all, other than maybe when you swap it in.
Yeah.
Um,
Yeah, absolutely.
yeah, it's definitely a very, very powerful system. So, how do you start up a job? Can we just talk really briefly about that? Like, say I wanted to go implement like the very basic part of the job system. Like, I want to go kick off a task where I calculate something a million times in the background and then give myself the result of that. What's the process for that like very basic sample setup to start pulling something in and just run something in the background on a background thread essentially?
Yeah, yeah. So it is kind of interesting the way you do it. You kind of set up a job in like a struct, um, and then I think that struct has to implement some interface. I can't remember exactly what it is, but basically you kind of like define the variables that you're going to need, and then the work that happens. One of the interesting things that you have to use is something known as like a native array. And then as you get into ECS programming, there's more options for native containers. So you have, native lists and native hash maps and stuff. But basically, this native array is a special type of array that you have to use in order to basically for your job to read data from as well as write data back to. And it has to be this special type of array because, again, we talked a little bit about the whole thing with the race conditions. And then, so this is basically just like a safe way to to store your data, and then that's how you actually end up reading it after the job is completed.
Okay, yeah, and if I remember, my understanding of the native arrays were essentially that they were kind of like a C++ array, essentially like an actual direct layout of the memory right there in order, and it's just kind of a more of a direct access way to get to it, unlike in C sharp where a lot of people don't realize it, but like even when you use an array, you've got multiple levels of object underneath there and all this stuff. Like, there's a whole layer of hierarchy and inheritance in C sharp stuff that people don't realize is there. And I think that's one of the things they're trying to optimize out with the job system. So that's why you're going into these more native data types.
Yeah,
But
yeah,
it's an easy
exactly.
transition, right? I forget the steps, but I'm sure you remember some copy to switch your data from a regular array to the native one. You run the data, and then you can just copy it right back out when you're done if you need to.
Yeah, yeah, it is pretty easy. I think the only thing that might trip people up is you basically define how long you want that array to live. So there's like different lengths that it can be, and then depending on the length, you'll have differing levels of performance for actually like creating these arrays and destroying them. So there's a temp array, which basically just lasts for that one single frame. You have a temp job array, and that's going to last for 4 frames, which is what you're going to end up using for jobs, because jobs don't necessarily happen just in that one single frame. They could happen over a couple frames. So that's why it persists for 4 frames. And then you can have a persistent native array, which basically just lasts the entire duration of your application until you manually destroy it.
Oh, okay. And then what are they normally picking? Is it just vary a lot depending on the use case, or is there one that's kind of like the default that most of the time is the one you're going with?
So it depends on your use case for that. So basically, if you know that your native array is going to be no longer used, or it's only going to be needed in that one single frame, then you can just allocate that particular native array type. If you are using a job, again, it's typically preferred to use the temp job. Um, and then if you are basically just like, you know that you have one native array that you're going to need to be constantly reading and writing from throughout your application, then you can use the persistent one. So basically, you just kind of want to go at like the lowest level of persistency allocation as possible for your needs.
That makes sense. I think that that seems like good advice there. For setting this up now, do they need to do anything to just start using the job system? They need to pull in any packages, go anywhere, download anything, or what's that process like?
Yeah, so I think you just need to import the jobs package from the package manager. It is officially a verified package now, so it's no longer in the preview phases. So there's no weirdness about downloading any preview packages from any weird repositories or whatever.
Nice. And now, does that one work with Unity 2021? I know there was a lot of talk about stuff not working with 2021. Does the job system work in 2021?
Yeah,
Or
great
do you want to talk
question.
about what does work in 2021, what doesn't? And
Yeah, yeah, I
yeah.
think that would be a helpful thing to point out to people. So yes, the job system does work in 2021. And kind of the reason that you asked this question, I guess, was because recently Unity announced that ECS as well as the other experimental dots packages are actually not compatible with the Unity 2021 editor as of now. And so basically, that just means that you have to use the 2020.3, the LTS version of the editor, in order to use those experimental packages. However, again, because the job system is a fully verified package, you can use that in Unity 2021. There are a few other DOS packages that are available to use in 2021. So they have like a new math library, which you can use. But again, like the ECS stuff, all the new physics stuff, you have to be using the 2020.3 LTS version as of right now.
Okay, cool. And that's just their long-term service release, their one that is supposed
Yeah.
to stay around for a long time. So they're supporting that. It's not in the newest versions yet. And from my understanding, that's supposed to come. There's just not a tight deadline on exactly when that's going to happen, when all of those things will be supported in Unity 2021, or if it happens at 2022, who knows?
Yeah, yeah. No, they're being a little bit cagey about it right now. Basically, they kind of explained in the forum post that they put up that they changed the way the package manager works in version 2021.1, and because of that, I guess there was some kind of complication with how the experimental packages are delivered. And then so I guess they just said, hey, let's just cut this off, and we'll make this only available on 2020 LTS. Now it is interesting. When I tested it out, I was able to still import the experimental ECS packages into my project. I set up a little test scene, and things were working fine. Um, and on the video that I did on my channel about it, I kind of asked people to see, if they were running into any problems. A couple of people just had some little minor things, but it seems like it still kind of works. But again, it's preferred just to use the long-term support version.
Yeah, that makes sense. I guess if you're using the experimental one, I mean, if you don't need to upgrade, then don't. But then again, it's hard when you're like using the experimental stuff. You tend to want to use the latest stuff all the time too. Like, I want to use all the new
Yeah.
stuff, not just one new thing.
No,
So,
I kind of see both sides. The way I look at it is like, if I'm using some experimental packages like dots and stuff like that, I would try to kind of like minimize the amount of experimental kind of variables going on. So I prefer using the LTS versions anyhow. So it's not really that big of a deal for me. And plus, I don't see anything in the Unity 2021 version that like would be like such a game changer and like help improve your ECS development workflow. I think the one thing that some people pointed to is these scriptable render pipelines are actually now tied to the version releases. So you can't necessarily use like the latest versions of the HDRP and all that.
Oh, okay. Yeah, that I could see being a minor issue, but I think you're probably right though. If you're using something like dots, or you're using the while it's in the experimental stage, you probably really don't want to be mixing in a lot of new stuff. I just like to do it for fun.
Yeah.
I
No,
like
I
to
get it. I
experiment a
get it.
lot
I
and
get it totally.
play with all the new toys and stuff. But I think if you're building a real project and you actually need dots in your project, you probably want to keep it as stable as possible, because using
Right.
experimental
Right.
stuff already on top of the latest builds gets scarier and scarier, because everything's working totally fine one day and then suddenly you realize like, oh, our stuff doesn't work on iPads anymore. We didn't
Yeah.
realize that, like, apparently
Yeah.
we upgraded a version last month and nothing works on iPads because we haven't checked it there, or some random thing breaks, and other problems just start to pop up. So I've run into it enough times that I'm trying to make sure I never upgrade anything before like a couple months out. I'm like 6 months out. Try not
Oh,
to
you
just.
don't upgrade a week before release?
I've done it. It doesn't work well. It's never been like, oh, I'm so glad I did that. I've had to upgrade after release though, because of
Okay.
emergencies. Like, oh, the only way I can either upgrade this or spend forever trying to fix it, I'm gonna
Yep.
upgrade it. But yeah, in general, it gets to be scary doing those big version upgrades near a release and everything just breaks. I remember we had one of the games we did was a lightsaber game in VR, and
Nice.
you would block shots with it, right? And everything worked great, perfectly fine. Everything was good. We were about to launch, and we grabbed an update for performance. There was like, it was back when VR stuff was really new, and like every update had huge performance boosts.
Oh,
So
yeah.
it
Okay.
was like, okay, if we update this now, I think it was like from 5.5 to 5.6, got like a
Oh.
20% frame rate increase.
Oh,
I'm like,
wow.
okay, perfect. Got it. Tried it out. Everything was good. Like the next day, realized that like there's some weird bug with the collisions in that version with our stuff, the way that it was set up, and like shots would just randomly get through and hit you and kill you.
That's
All from
interesting. I
upgrading
think I
the version.
remember some of those collision bugs in version 5.6. That's when I was doing some college projects back then, and like there were like just like weird collisions happening out of nowhere. I'm like, that's not supposed to happen.
I'm glad it wasn't just us, because yeah, I was
Yeah,
like, this doesn't make sense.
that's
Like,
funny.
I'm just
Yeah.
getting hit. Like nothing changed. So we didn't change the code. The colliders look good. It's just going through. I don't get it.
Yeah.
Yeah. So yeah, that was an interesting one. Had to go back and revert everything. Go back, try to get it all working again. Luckily, with source control, it's not too bad, but it's
Nice.
definitely a lesson there, or a reminder of a lesson. Like, don't upgrade before release, dummy. Anyway, let's jump into some other dot stuff in ECS if you don't mind.
Yeah.
So
Yeah.
we talked a little bit about the job system and how you can use it to kick stuff off asynchronously, basically running stuff on another thread from your own scripts, your own mono behaviors or scriptable objects or regular C# scripts, whatever they
Yeah.
are. Um, but what about the whole entity component system? How does that tie in? How do you use that? Do you use that? Like what's that like? Can you give an overview of that and just an example of where we would use it and how we go about that?
Yeah, yeah, totally. So the entity component system, for starters, it's not actually one thing. Like you hear entity component system, it's not like the system of entity components or whatever. It's actually three separate things. So you have entities, components, and systems. So I can just break that down real quick for everyone. So basically, entities, they're basically nothing. They're kind of just like pointers to components, which I'll talk about in a second. But ECS programming is different than object-oriented programming, where object-oriented programming, you of course have one single object, and then on that you have a bunch of variables, you have all kinds of functions inside of that. So ECS programming, it's a data-oriented way of thinking of programming, and so the entities, components, and systems are basically all kind of separated from each other. So the entities, they're basically just a pointer to data components. And then the data components is just basically what stores the data. It's just raw data. If you have player health, movement speed, any kind of data that you want, any sort of properties that you want to have, any current values that you want to keep track of, those are all stored in components. And then finally, you have systems. And then systems, basically, the way that you use them in Unity's ECS is you can kind of filter out by component. So you can say, find me everything with this component, and this component, and then I'm going to do some operations on them. So it
It'd be
doesn't
like all the
necessarily,
enemies that can move and have health, like
yeah,
that have all three of those components, like an enemy component, a health component, and a move component, right? And then you could
exactly.
act on those.
Yeah, exactly. So it doesn't really necessarily care about the entities. You're kind of just like filtering out by data at that point. And then the systems basically just run operations across all those entities or across all those data components. And the way it's super efficient is because all the data components, all the like data components are stored right next to each other in memory. So then that way, when your computer basically goes into the RAM, when your CPU goes into the RAM and pulls some data from that, the data next to it from the other components is going to be basically already be stored in cache. Because when it grabs that one single data component, it's actually going to grab like the whole block and just bring that right into cache. And then that way, when you're processing them, it can just go into the cache, which is much faster than going back to the RAM to find another location in memory to pull that data from and do some operations on it.
Right. Can we? I wish I had like a graphic here to represent this and show it and to break it down for everybody. But essentially, correct me if I'm wrong, but you're pulling in memory from the RAM. So you've got like all of these components here, all of your health components, and they're all laid out in memory sequentially. You're pulling in some of them or some chunk of them all at once, and then being able to process them all at once. With the object system, you're not able to do that. You're pulling in one. You're pulling in one at a time from RAM into the CPU's cache, acting on it, and then requesting the next one. With this, you're
Yeah,
essentially able to pull in a bunch of them because the cache on the CPU holds a lot more than just one variable for health. It holds a lot more than one integer, right? So you can pull in all of these ints and then loop through them and process them and cut out basically all of that middleman work between the RAM and the CPU. That basically
yeah,
where that performance is coming from, or a portion of the
yeah.
performance.
Yeah, exactly. And just for kind of context, the terms are cache hit and cache miss. So cache hit is basically the data is already stored in the CPU cache and it can just access it right away. And then a cache miss is when the data is not in the CPU already and it has to actually go back to RAM to find that.
Yeah. And the CPU cache, for anybody that doesn't know that, is just it's memory on the CPU. It's
Yeah,
really high speed
exactly.
memory that's literally like on the CPU die instead of on that separate RAM chip that you've got in your computer.
Yeah, yeah. When you're looking at CPU specs, you'll often see different levels of cache. So you'll see like L1 cache, that's going to be the closest to the CPU cores, and it's typically the smallest. Then you'll have like a level 2 cache and a level 3 cache.
Yeah. And now that amount of cache has gotten relatively large on CPUs too, as they grow and grow and grow and they get faster.
Yeah,
So
I got
being
like
able to cache a lot in
70
there is good.
megabytes of cache or something ridiculous in my computer.
So you start to see big performance increases from this stuff. So okay, I guess you're going through dots. I guess you want to just dive in more about it. Yeah, let's talk more about dots. Go ahead. I kind of interrupted you there on how we were caching the data and stuff. But so you got all your data there. You're acting on it in the systems, and then where do you go from there?
Yeah. And so yeah, I guess within systems, basically the way that we can get multi-threaded performance is integrating with the job system. And Unity gives you a really easy way to basically create jobs within systems, kind of automatically using this like entities.forEach function is typically the easiest way. Basically kind of the structure of how you do it is you say inside your system, you say entities.forEach, and then you kind of end up doing like a lambda function, but you actually define the like data that you need reference to. So any data that you want to, you need to determine which data you want to read and write from, and then if there's any data that you only need read-only access to, because that's going to be, a little bit more efficient to just get the read-only access. So you kind of filter out by components within that for each section, and then kind of within the body of that, that's where you define the work that you actually want to happen. And then if you're using only blittable data types, then at the end of that, you can actually do a dot schedule parallel. And then so that will schedule that work to happen across any multiple threads in parallel.
Okay, so you just kick off, you write up a for each loop, and then you kick it off to run in parallel. And then does that just you just run that indefinitely, that system indefinitely, or do you have to like restart and manage and maintain that? How does that all work, or how do you initially kick off your job? So say I've got this. Let's just put together an example, if for the watchers, right? Like say
Yeah,
they've
yeah, I
got an
think that a
NPC
good
that
concrete
moves, like
example
it's
would be
got
helpful.
an NPC component on it that maybe is just like health and that's it, and then a mover component on it. Um, how do they go about making the job actually fire off and work? So like they've written up this job script, they've written up I guess it's a struct, right? The struct that inherits from a job type.
So yeah, there's different ways that you can set it up. If you're doing it in the traditional sense, you'd have to like set up the struct and assign all the variables and everything like that. Unity's made it a little bit easier now. For the system code, you can basically inherit your class from it's called system base is the base class. And then that script has like a little bit of a life cycle on its own. So there's an on create function, which is basically similar to like the awake function in Manu behaviors. And then you can, set up some just kind of basic things in there. And then the main one, that is actually required is a required method for the class is the on update class. And that's very similar to just a normal update function where it kicks off every single frame. And then inside there, that's where you are typically going to be defining your for each function. And then basically the only thing you need to do to schedule the jobs is at the end, you just do a dot schedule parallel. Now, if for some reason you can't run it in parallel, there is a dot schedule method that you put at the end of that for each function. And then, so that basically just designates to run the work on a different thread than the main thread, but it doesn't necessarily run in parallel to the main thread. And then finally, if you're using some non-blittable data types, or you're just kind of doing something that Unity doesn't allow you to schedule, then you can do a dot run, and then that will run that system on the main thread. So there's kind of some different options depending on what you're doing.
Okay, so you actually have quite a bit of control there in how you set it up. So I wanted to get at least one more question about the ECS setup and just how you generally architect it. But what would a normal like entity setup look like? How do you build an actual entity, and how do you lay that out? Say we have like a very simple, let's say like it's a tower defense game. What would some of my entities and components be in like a standard tower defense game where I'm placing down towers and little units are walking by and things are shooting at them, trying to stop them from getting to the end goal? What would be a couple entities there? What does that kind of look like? Just trying to get an idea of how you're envisioning this, and how somebody watching this, they want to build a game using ECS. Like, how do they think about the structure of that?
Yeah, that's a great question. So you definitely want to think, it's data-oriented programming. So you really want to start with the data objects. It can be helpful to kind of list out the things that you want in your game. Oh, I want towers, I want enemies walking around, and then from there you can kind of see, what data do these all need? Is the enemies running around? They're going to need like kind of like a move speed component. We're going to need to keep track of their transform, things like this. And you kind of want to break your data components out as small as possible. And the reason you do that is because it's actually preferred to share data components across multiple different entities, as opposed to just having one big data component that just contains everything about the tower, or everything about the enemy. you want to break them up into these kind of smaller components. And then that gives you a lot of cool options that you can do. You can easily just kind of swap in and out components to change behavior in your game. I think that's one of the coolest things about the entity component system is just how easy it is to swap data components around, and just kind of be able to just add and remove behavior from different entities. Um, and so the way it's actually created in Unity, there's a couple ways that you can do it. But the way that they've kind of seemed to be pushing is what's known as the conversion workflow. And so you can basically just create your just regular, game objects inside Unity, get your scene all figured out, figure out what prefabs you want and all that. And then when you define your data components, you can actually add an attribute to the top of that data component, which is called the generate authoring component. And then that will allow you to actually drag that data component onto your game object inside Unity. And then if you have the convert to entity component on that object as well, when you hit the play button, it'll actually convert that game object into an entity. So all the so what the authoring component does is it basically takes that mono behavior component. It's going to generate a data component from that, and then it's going to send all those values that you have set in the editor over to the data component.
Oh wow. Yeah, that's really cool. I think that's
Yeah.
gonna make it extremely accessible for people. And that's something people can just use right now, right? They can just take it in, set up the components and just do the conversion and it just works.
Yep. Yep. Yeah. You just need to make sure that you import all the Unity ECS packages, of course. It's kind of a little weird how you have to do it now. I have some videos on my channel talking about how you actually import the packages into your project. Basically, what you have to do is in the package manager, because these are experimental packages and they kind of hide them away from you. You actually have to find there's a specific URL that you need to add in. So in the package manager, there's a little plus icon, and then you say like add package from get URL, and then you can just put that URL inside the package manager there, and then that'll give you the ECS packages that you need.
Okay, and we'll link that video too, so people can go watch the video, see the
Yeah,
exact
yeah,
steps, and
totally.
go through and actually set it up, find that URL, and get it working. Because I think that's really cool. That it leads me to one more thing that I wanted to just ask you about, which is just kind of the future of dots and ECS. I'm sure people ask you all the time, "What's the future of it?" And I'm sure you don't have any secret inside knowledge that you'd be able to share or anything. If you
Yeah.
had any secret inside knowledge, they wouldn't let you share it,
Yeah,
right?
breaking
But
news right here. No.
but one of the theories that I've heard a lot is that a lot of the stuff that's in ECS and dots will slowly kind of migrate to just be more native, so that you're using it without even sometimes realizing that you're using it. That a lot of the stuff will just kind of automatically happen, at least in the spots where they can make that happen, because they can just make it more accessible and get the benefits out there without having to do much retraining. How likely do you think that is that it's gonna, a lot of the things are gonna be brought into just the standard existing workflow, and that workflow change is gonna be pretty similar? Or how much of that do you think is like there's still gonna be a large amount of training long term? So I mean, I'm thinking like 5 years down the road, like do you imagine dots being a thing that you have to learn separately, or is it just like you learned Unity and now of course you know dots too because it's part of like the regular Unity workflow and it's really integrated in and just kind of I'm curious like where you think that's going to be. I have no idea, and every time I try to guess on these things, I'm
Yeah,
like
yeah,
way
you're asking
off.
some big
So I've
questions
given
there,
up
man.
on guessing like what's going to be popular, what companies are going to do, and everything. I never ever get it right. So
Yeah.
I'm just kind of curious what your thoughts are.
Yeah, no, those are some good questions. So Unity has said that they're trying to do their best to integrate dots into the existing workflow as much as possible. And so that's kind of what you see with the conversion workflow. So if you're familiar with just using Unity as normal, dealing with prefabs and adding components to them and everything, you can definitely get the hang of the conversion workflow pretty easily. There still is definitely a learning curve to, creating data components. You can also create your own custom authoring components, which is something fun to do. It's really similar to like making custom inspectors or something like that. Um, but Unity is definitely trying to make it so if you know how to use Unity, you can understand how to learn dots. I think there's still probably going to be a separation at some point, just because it is kind of a different way of thinking about how you plan out your architecture for your game, how you actually go about implementing it. But I think they still are looking into some like visual scripting options for dots. And so that'll be interesting to see how that differs from the existing visual scripting stack. So yeah, I think, I mean, again, they've definitely said that they're um, trying to make it as user friendly as possible for people who are already existing Unity users to use the data oriented technology stack. And actually, one thing, um, kind of on the whole forum post about how Unity dots, the experimental packages, are not compatible with Unity 2021. There was kind of like a bunch of kind of like conspiracies going around about how they're making like a whole like separate editor for the Unity dots that kind of runs on dots on the back end. So I don't think that's going to be the case, but there are people saying that they think that's what's going to happen.
Interesting.
Yeah.
Yeah. I wonder if that's just like a one of those internal experiments, where somebody wants to do it and they just do it and it gets out. Like they're just doing it for fun. Like I always wondered if that's what happened with like the Linux editor for Unity. Just like somebody really liked Linux and they're like, I'm making a Linux editor. Like I'll do it in my spare time or whatever. I'll
Yeah,
get the
right.
approval. I'm doing it. Yeah. But that's I'm glad they did it though, to be honest. Like, don't get me wrong. Like Linux editor was a good thing because we do Linux builds and sometimes it can be handy. But
For sure,
yeah,
yeah.
just curious. I wonder about those things. I've seen it in a lot of companies before where I've been working and people just have these projects that they want to do and then it becomes a whole thing. Sometimes it becomes a new game. Like they're just like, I'm gonna go work on the side project. And
Yeah,
the next thing
yeah.
I know, like that's like the leading game that we're working on. Anyway, I think that it's very interesting stuff like the performance and just dots in general and understanding the tech stack and the benefits of it too and just how you can use it to optimize performance and really speed things up and to really what I've seen it do the best is push the boundaries of what you can build with games. They allow you to build insane things where you've got crazy scale of stuff. I mean, that's kind of what they demo too, is what Unity focused on demoing. But it's one
Yeah.
of the coolest parts. Right? I mean, saving battery power and saving performance and running good on old devices is cool and
Mhm.
fun and stuff. But it's not nearly as flashy as exciting as like running something that you can't normally run anywhere else because
Yeah,
you can
yeah.
run these things that you can run on a slow device
Yeah,
on the fast one
maybe not as
anyway.
practical, but, it's cool.
Yeah, yeah, it's the fun and exciting things, right, that really push it. All right, Johnny, I just wanted to say thanks again for coming on here, man, and just sharing some of this dots info and the job system stuff. I think there's definitely some actionable stuff here for people. They need to at least go check out the job system, see if it's something that they can take advantage of in their games, and get a good overview and idea of how to use dots and what's coming down the line and all of that. So I want to have everybody just go take a look at Johnny's channel, go subscribe, hit the thumbs up button on at least one of those videos and the alert so you can get an idea of what's coming up next and just get notified about it. Understand what's new in Unity and what you'll be learning about in the future and what you can start to use right now to really push the boundaries or just gain giant performance improvements. Improvements? That's the right word. Anyway, thanks again, Johnny. Is there anything that you would recommend people go look at first or just start taking a look at if they want to dive into jobs or dots or ECS or any of this stuff, or just don't kind of want to worry about or talk about performance or think about performance? Something that you
Yeah.
would point them to?
Yeah, totally. First of all, thanks for having me, Jason. I really appreciate that, and I hope the viewers found this video, valuable in some way.
They did.
Um,
They already hit
awesome.
the like button and
I'm
subscribe
sure.
and stuff,
Yeah,
and they'll comment down below, I assume.
we got
And
great
yeah, if you
viewers.
guys do like this stuff, you want to hear more about dots, make sure you drop a comment down below because we'll do more and more of these. And we'll
Yeah,
talk more
please
about
do.
this
I
stuff.
mean, we're basically just scratching the surface here. But yeah, I mean, if this is kind of like your first introduction to dots and ECS, I think a great place to start. I got a video on my channel basically showing you how to set up a new project in Unity ECS. I think that'll kind of like get you up and running, and then you can kind of start following along with some of my other videos where I talk about, how to actually implement entities, components, and systems. So I think that would be a great place to start. I think right now is a great time to get into ECS because it's still kind of like in the early experimental phases, but there is awesome performance benefits that you can take advantage of. It's if you're doing some basic things, it's going to be pretty solid for you. And I think there are a ton of awesome possibilities for ECS and dots in general in the future.
Yeah, I totally agree. A lot of the big games that I know are using, at the very least, some of the job system for performance benefits to do things that they just need to push the boundaries
Yeah.
on, or to just fix performance in specific spots where they want to do cool things, but they also want to be able to support a wide audience. So it's definitely not something that you just want to ignore and push off. You go check it out. So make sure that you hit the like button and then go click over to Johnny's videos and just start watching them. Go check them out and get used to the system. And thanks again, Johnny, for coming out. I really appreciate it. And thanks again, everybody, for watching, hitting that button, and checking out Johnny's stuff and subscribing to him as well.
Awesome. Thanks again, Jason. Later, everybody.
Thanks.